create some API key from a couple of open source model providers. I will cover them again, so it's not necessary that you would have already done that. If you've done it, good. If not, I will be helping you too. I'll not spend too much time, but I will, show you step by step how exactly to get access to those API tokens. And once we have it, how do we implement it? All right. I will be asking some questions, because it's a large audience. It won't be feasible for me to go to every one of your queries or allow an unmute. But um, I expect, just for hygiene purposes, if you are understanding the concept, whenever I ask for it, give me a confirmation. If you have questions around it, please pose a question. So every now and then I'll be waiting for, or just taking the queries that you have until that point in time, and then trying to address them. All right. Just give me 1 minute, I think less than a minute, guys. I'll probably rejoin because I need to share the screen. There's some problem.
So in the meanwhile, sirs join back. I'll just take another poll to understand your familiarity with the tool. It's there in front of your screen.
All right. Sorry for that. I think things should be fine now. I'll share my screen. Okay. So we'll be talking about a few things. We'll talk about an overview of large language models. It is very likely that you have been using it in some form or the other, something as basic as ChatGPT or something much more advanced as open source models and building your applications with it. Of course, the idea is not to go into all level of detail, but to understand what are the various aspects. Um, as I said, a little bit about what are the architectures that power it. There are some basic concepts that are important, like just when I say what time is it, you'll probably say it's a certain time, or how much time will it take to reach point A to point B, you'll probably say an hour. How much money will it take? So thinking about basic things like what is the units or currency of large language models, why are they important, and stuff like that, right? So we'll be talking about some of these aspects as we go along. We'll do some hands-on stuff as well. It should not take a lot of time. We are almost 2.5, 3 years into when large language models have already become popular. So you're already using it. But there are a few other options that you can look at. We'll talk very briefly about it. We'll do some hands-on. So my idea is that whenever I say an API, basically what we mean is think of a general setup that you have with an LLM. You go to ChatGPT or Claude or Gemini, for example. What you would do is that you would put in your question, you will ask it to reformat something, summarize something, explain something, whatever your use case is. But that is going to a different window and then asking it to do something. But what if you want to build an application, right? Now, whenever you want to do all of that, it is always a good idea that you are able to get a large language model, its capabilities into your system, right? I don't want to have a different interface. Yes, it has its own benefits and use cases, but we really want to make sure that we also have the ability to build with it. All right. So that's something that we will explore. Um, that's basically what I want to cover. I'll start with the first topic. Before that, if there are any quick questions, I'll just look at the chat and try and answer them. If there's nothing significant, I'll start with the first topic of the day. Okay. Abbas already has good experience in terms of using a UI with Gemini API. Good. Uh, cool. I don't see any specific questions at this point. All right. So we'll get started. Again, Deepali already gave a quick introduction. Very quickly, I have total of about 14 years of experience. I currently work as a data scientist with Atlassian. Um, I have been working a lot on data science for the most part of my career, moved to machine learning about 7 or 8 years back, and increasingly work in the last 3 to 4 years on large language models and integrating the large language models into some of the traditional NLP workflows or building out products that are AI native, right? So that's broadly my experience. Um, okay, so again, a very high level overview before we go into the architecture piece of it. So AI systems are trained on massive text data, right? If you ask it, what is the origin of pizza? If you ask it some specific event, if you ask it some reasoning task, it is able to do all of that. It is only able to do it because it has an understanding of so much different context that it has learned on, right? Think of internet scale information. Uh, it knows things about statistics. It knows things about biology. Maybe it also knows things about your favorite TV show, right? It knows all of it because it has seen that data. Okay, LLMs are not necessarily novel in the sense that they may be able to generate something new that it has not seen, but that is mostly far and few between. We are talking about use cases where all of the information that is out there, right? At least freely available. If you're in an enterprise, if that's your personal data and a large language model does not have access to it, it would not be trained on that data, right? But in general, what it does is that it predicts the next token. That is how we probably think of a concept and then we try to put it in words. Large language models are different. Large language models would kind of, so if you ask it, what is the Himalayas, for example, the first token would get generated, and then it might look at the entire sequence and again predict that Himalayas are one of the biggest mountains, blah, 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 right? So it will look at one token after the other. So at its most fundamental level, that is what we're talking about, right? It has the ability to look at so much of data, consume it, contextualize it, but also be able to follow tasks, right? Think of somebody or a computer or a robot that has access to all the information, but it is able to do what we are asking it to do, which is by itself something that is extremely useful. Okay. Again, novelty versus what is out there and it has learned. Novelty almost zero, but things that there are out there, right? It is about how well large language models can use them. Okay, so some of the very fundamental things, I'm very sure you guys have done it. We will also have the option to um, I'll go into one of the aspects slowly, and then we'll open a chat bot and I'll show you how to do some of the basic stuff. and then we'll do the architecture piece of it. So content generation, maybe you are a programmer, maybe you do Java, maybe you do Python, maybe you are a consultant and then you do a lot of, let's say, deep dive analysis or recommendations for your end clients and stuff like that, right? So whenever all of these things happen, it is able to generate new content. Up until the large language models became mainstream, that was November 2022. There was no model, I would say, that had the ability to generate text of its own, right? We could train it certain patterns, we could do some predictions, but it would not generate a lot of text, right? Even before that, these models were already available, but they were no close to this level of intelligence or the level of access, right? We did not know about this technology in general by and far. So it can generate a lot of text. There is text versatility, maybe talk in a terse manner, talk, um, in a very verbose manner, for example, think about something before responding, analyze some data, analyze some situations, and provide an output, right? So all of these are available. Few short learning. Generally, it is possible that large language models do not know your specific domain, your specific data, and your specific context. Now, there is something called few shot learning. Few shot is a very fancy term for simply saying that what are the examples? Okay. Uh, like in your context, X equals 2, and then eventually you do some reasoning on top of that, and then you get a specific output, right? So when you want to give it certain examples, right? Few short is few examples. Okay. So it can adapt to the task. Now, in general, what we're talking about is um, it can learn what you are trying to say or try to adapt to your domain or your use case using a few examples, right? That's basically some of the abilities. And again, I'm very sure you guys have used it. We will still, spend a couple of minutes going through some of the best options and have a look. Okay. Now, this is going to be a little bit of the architectural overview. Couple of things before I start this. Firstly, it is extremely dense as a concept. Okay. So unless you have a background in, say, data science or machine learning or computer science for that matter, um, I would not worry too much about it because this is not going to be uh, the question that I will receive in my interview or something that I need to use. Okay. But because we have seen that the large language models are extremely powerful, they seem to understand fundamental things as well, right? Like as an example, let's say I'll open a new one. I'll write an example to show what I mean. I went for tea outside and it was hot. Okay. Now, any guesses what is the meaning of it in this particular context? I went for tea outside. It was hot. Now, tea can be hot or the weather is something that can be hot, right? It can be both. It seems it could be tea, but we cannot be sure, right? And this is how we write. This is how normal people write, where they ask, but they do not necessarily specify exactly what they're looking for. English as a language also allows for so many different meanings and syntactic relationships, right? So how does a machine understand what do you really mean, right? And this is a very, very small and simple example, but what we're trying to do over here is trying to establish a relationship between the various options that we see. Okay. So there is something called self-attention. All right. This is, again, it will be headline only. I'll not be going into a lot of detail over here, but only when, right? Think of it very logically. only when the system or the architecture that a large language model is built on has actually seen this entire context or generally learned how English as a language typically works, would it be able to understand what does it attend to over in this particular case? Yeah, like for as an example, um, go out and go out to the let's add please, right? So when I say please go out to the store and get some coffee, okay, if we are looking for instructions or commands, right? Go store coffee is enough. If I'm looking for if somebody is being polite or maybe the tone, maybe I will focus on please. So whenever there is some text, the general point I'm trying to highlight is whenever we have some text, the model, and it could be any model for that matter. Here we're talking about specific model called transformers. I'll come to that. But there needs to be an understanding of what are we trying to look at, what relates to which different word, and how does it all come together, right? So we need a very complicated, a very smart, a very intelligent model that is able to provide us with this. Okay. So if I go here, there's something called self-attention, right? There is in the year 2017, right? Google put out a paper which launched something called transformers. It's a model which can understand a lot of complex relationships. It can scale very well. And since then, there have been a few modifications to this architecture, but the core idea still remains the same, right? Where what I'm saying is we are going to have attention of every token, let's just call it simple word, to every other word. Okay. Until and unless there is a back-end architecture that is able to make sense of every word to every other word, this is not going to work, right? And transformers is the architecture, more specifically, its module that is called self-attention. So please, as one word, will need to understand what is its relationship to every other word that I have. And every other word also needs to do the same thing. Think of it as an n cross n matrix that will actually tell you how are the words actually related, how important they are, etc. Okay. So that's basically your self-attention. Now, there is a lot of text that is available on the internet that can be scraped and used for training these models. So these are already trained. And then what is fine tuning? Fine tuning is adapting it to your specific use case. Your specific use case is looking at a restaurant. Okay. I stay in Bangalore. There is a specific restaurant which is very famous called Toit. Okay. Now, if you see uh, some of the reviews, you are, let's say, a manager at Toit, your responsibility might be to understand how are people feeling about your experiences at this particular restaurant. Okay. Now it is like, if we did not have this technology, the only option was that you would go step by step, look at all of these, make a note of what seems good, what seem to be the improvement points, etc., etc. Right? But now with this advent of LLMs, but even earlier technologies such as the transformers, we are able to really synthesize a lot of this information and understand if something is positive, negative. Why are we able to do that? Because whenever it has learned from internet the different syntactic relationships, the deeper relationships, what word comes after what is something that is a good grammar, etc., etc., right? It has actually learned all of those relationships already. And you can fine tune it. Fine tune essentially means that you are great. You are a great candidate in the market who is a consultant on energy based projects, right? Now, I want to hire you for, say, automotive companies, right? So you are still great. You still have a lot of knowledge, great frameworks, great communication skills, great eye for attention and analysis. Now, do whatever you used to do for energy sector, please do it for automotive sector. The foundations, a lot of it remain the same, but we want to make sure that the same things are now adapted for a different use case. Okay, that's basically fine tuning. So whenever we think of large language models, they have the ability to um, adapt itself to a specific use case. You might even say that I had great food is a negative review. Okay, and the other way around. If you do that, the system can still function the way that you want it to, which means instruction following is smart. It does not have to make sense. It will still follow the instructions given. The system that you've set up along with the LLMs is sound enough. Okay. There are various components. Again, not going into the detail. We want the session to be a bit more uh, hands-on as well. So I'll spend time talking about all of those things. There's something called embeddings. I told you a few minutes ago that any machine, any algorithm, the most advanced that you see with these large language models today, they do not understand what any word really is. It does not understand what is an LLM, but it is able to give us very good responses, right? It is able to contextually understand, do whatever we are asking it to do, right? The way it is able to do it is that it converts those words into something that is known as tokens. So think of tokens as simply something that is a word. One word is a token roughly. Okay. There are some complications. I'll come to that in some time. But in general, I'll give a very simple example. Tiger and lion. Yes. Do you think these two are related in some form? Both of them are wild animals. Both of them are sometimes found in zoo. Yes. But is a tiger word related to, say, a pond? Right? The answer is not really. You can make a case that, you know, tiger can go to the pond to drink water. That is a legitimate relationship that we have established. But tiger and lion are closely related. Both of them are animals. Both of them are wild animals. Both of them have very similar attributes, right? They're different in some ways, but they are closely related. Tiger and pond is still related, as I said. You can make a case that tiger went to the pond to drink water. So there is some relationship that you can draw, but it is not close. So I did not say that it is not related. There is a degree of relationship. Tiger and lion are very closely related. Tiger and pond are still related in some form, but not too closely, which means we should have numbers. Let's say, again, these are all random numbers. Let's say tiger is represented in the entire embedding space with a number 950. Maybe lion is close to it at 980. So whenever we are talking about something similar, right, logical things pop up. Okay. Tiger and pond, for example, tiger is again 950, but a pond may be, 12,000 something. Okay. Yes, there is a degree of relationship, but it is farther away. So the way that the transformer architecture works is that it tries to synthesize all of this information of all the web scraped information. How does English generally work? How does reasoning generally work and stuff like that, by trying to establish relationship of every single thing to every other single thing. Okay. It can be close, it can be far, but there is a relationship. All right, that's basically uh, what embeddings really help us do. Attention, self-attention, similar concept. Basically, what we're trying to do is figure out how everything is related to everything else. And then there are certain other conceptual stuff. I'm not going into the details for that. Uh, at the end of the class, I will be sharing this deck. So you can look at some of the details then. Okay, so I talked about this slide, so I'm not spending more time. It is a deep learning. So there is, think of it as, again, I'll write it down for easier understanding. There still is stats, statistical modeling. Then there is ensemble modeling. Then there is deep learning. One of the types of deep learning or neural network is transformers, right? So just so that we are grounding ourselves in understanding of what is this architecture all about. Okay. It is an advanced form of some sort of data science machine learning models. Okay. Uh, all right. So we talked about transformers, how does it work and stuff like that. Again, there are some details. I think we're bit short on time. I'll move on to the next slide. Maybe I'll come back to you to this slide if we have time towards the end. Accessing LLM through UIs. Again, just sharing this. I am very confident you guys have access and have been continuously working with very regular LLMs such as ChatGPT. If you can put it on the chat, my question to you is specifically, which LLMs have you used through a chatbot, right? ChatGPT might be one of the most common, but apart from ChatGPT, if you have used any other large language models through the chatbot specifically, Gemini, Grok, Claude, Perplexity is like gatherer of multiple LLMs, Hugging Face maybe. Okay, we have Varun saying all of it. Okay, great. ChatGPT, Gemini, Perplexity, good. Claude, DeepSeek, awesome. What about others? Deepali, is the chat open for everyone?
Yes, it's open.
Okay, okay. Folks, if on the chat, you guys can mention if there are large language models that you have used, which ones specifically? Ruhika has used Gemini, ChatGPT, Perplexity. Okay. So yeah, good point, everyone. Just one clarification. Perplexity is just trying to gather multiple LLMs and providing it to us in a single interface. Okay. It is not a large language model by itself. They do have a model of their own, but that's not such a great model or something that people generally use. Okay. So I'll explain it this way. Um, Gemini, OpenAI, Grok. Yes, good. Lin, Copilot. Okay. Lin, thank you for that. Claude, Perplexity, Nitish, Olama. Okay, perfect. Good. So yeah, you have been accessing it not just through, but also download like through a UI, but also accessing it through API of downloading it on your own system, right? Now, the couple of things that you should be aware of. Um, First is all of these are proprietary tools, right? What do we mean by that? There is concept of proprietary or closed source models, and then there is open source models, right? So we have both of these. Now, the this is an important distinction to be made, because if you are going to use large language models in your enterprise environment, or you are going to build any applications, workflows, agents through all of these, right? Uh, Again, both of them have their place. Like for example, um, these are all your OpenAI, which has ChatGPT as the consumer-facing app. Then there is Anthropic, Claude, there is Gemini, there is Grok, right? So these are some of the major players that we have. Gemini is from Google. Okay. This is by XAI or Twitter. Okay. In general, what are we trying to say is that when we say closed source or proprietary, there is no way for you to download any of these models on your local system. Doesn't matter how good your hardware is, or you cannot even have access to it on a specific server or anything, right? You can access them only through a specific API. You send them what is your question, you send them what is your context. Okay, that's it. And then they will give you a response. All right. Open source models, on the other hand, these are actually open weight models. There's a distinction to be made. Not the most important thing in the world, but since we're talking about it, if your system is powerful enough, okay, or a third party provider can download it on their GPU and you can access it through that. Or the open source model provider themselves can give you that access. Okay. So now what is good or bad about these things? All right. I'm just putting out certain pointers. When I talk about closed source models, as I said, you send task, context, get output. Okay, there's nothing else that you can control about these, right? Open source, which means you have access, again, assuming you have a system that is powerful enough. If you have a 4 GB laptop, likely none of the models would run on your system. If you have 8 GB, very difficult. But maybe some of the small language models can work, like small LM or some of the smaller Llama models, some of the small Quen models, and so on. Uh, right? You can use for free or whatever your hardware costs are. Okay. But most importantly, you can fine tune them. You can also fine tune the closed source models. Don't get me wrong. It's not as if that model is final and you cannot give your data to it so that it will adapt its behavior to what you are trying to say. It does. Okay. But generally, even that model is not accessible to you. Okay. You cannot have it in your environment. You give it your data, that model will be fine tuned. It will now behave the way that you want it to behave on your data. Maybe your uh, manner of speaking is different. Maybe your specific domain knowledge is different. Yes, that model can be changed, but you will still access it only through an API. It is expensive to do that. Okay. So most of these providers allow you to do that, but it's a bit tricky. Here, you have complete access to change the model and learn a little bit about its behavior, its core architecture. Maybe if you are interested enough or that is a need for your enterprise, maybe you are able to learn and how to create a model of your own, right? Even that is possible. Now, coming to the distinction between open weight and open source. Anybody in the chat wants to reply, what is the difference between open weight and open source? I already said that either of these you are able to get the model um, yourself. You can use it for free if that's your hardware, or you can change some of the behavior of these models. What is the difference for open weight and open source? We have Ahmed Raza. Open weights are a bit restrictive, especially for commercial use. Yeah, okay. So it really depends on the licensing, but I understand what you're saying. It's possible that they have a license where you can use it, but you can't use it for, putting in front of a customer, end customer. So that's possible. Some of the Llama models have it and so on. But what specifically is the difference between open weight and open source? Anyone? Yeah, recordings will be made available. Don't worry about it. Yes, open sources, but the source code underlying source is not shared, but the weights can be modified. Okay. So you guys are close. You guys are close. Okay. If you already are at a level where you understand at least open source, which is what the general term for these models that you can download are, I'll explain what these are. Okay. First is licensing. It can be a case where, if let's say Gemma, for example, from Google, right? They had a restrictive license, I believe. You maybe could not use it for all commercial purposes. So that's one of the aspects. But open source means you have the weights or uh, sorry, sorry. Open weights means you have the weights, parameters, and you can run it. That's all. Like, you are not aware of what was the training data. If any one of you has background in data science or machine learning, what is a model, right? A model is input data, then there is an algo, and then there is a trained model, and then you use this model for doing inference, right? That's all there is to it. Open weights, you don't have access to the input data, you don't have access to the algorithm, you just have access to the final model that you can use for inference. Inference is chatting with it or whatever you want. Correct? That is open weights. Open source in its truest sense is everything. Okay. So they will actually give you the data. They will tell you what was the exact algorithm, what was the exact parameters that were used in the algorithm to train the model. So you, if you have good enough hardware, or you can rent a GPU somewhere and try this out for yourself. Okay. This is very important because if there are open weight models, open source models in its truest sense, right? You are able to get, I think Snowflake had some models which you can check that out if anybody is interested. Snowflake had some LLMs which they had, I think a year or so back, they had open sourced it in its truest sense, which means given a good hardware, you are able to train a model of your own. Okay. And then modify it, like you give it your own data and then you have your own large language models. Okay. Yes. Amir Ranjan, that's perfect, right? You only get the trained parameters, which is also good enough. You still have a lot of control over it. But you are constrained a little bit in terms of understanding how it was trained. Okay. So that's basically some of the changes. Uh, okay. So that's that. Now, again, I believe I'll not be going into very basic stuff, but when you have access to any of these LLMs, it is always a good idea to try it out. Not all models are the same. By far, they are not the same. Okay. What I mean by that is, if you would have seen something like an LM Arena. If all of you can open it on your systems, large models arena, I believe this is what it is called. If I ask it, create a Python workflow for um, text clustering. You can put in some different prompt, that's fine. So it will give you answers from two different models. Okay. We don't know which of these two models really are. But depending on the outcomes that these models are generating, you are able to rate it. Do you feel the assistant A is better or assistant B is better? Okay. So when people like us, developers or anybody else who is also interested in using the large language models, gives their, so they are not able to see which model is A, which model is B, of course. That's the whole point of it, right? Depending on this, they get good scores. So a lot of these scores are nothing but the leaderboard. Okay, so let's open the leaderboard quickly. It tells you which model seems to be preferred by the folks like us or whoever has done this test. So there are 56,000, 52,000 people who have tested out the Gemini model. They did not know, of course, that this was a Gemini model, but it gave the highest score. And it has, and then Claude Sonnet and Opus, and yeah, of course, the best models that we might already be using on a regular basis. That is something that is already coming up at top, right? But this is human preference. Make sense? This is what you felt is good or not on your specific task, maybe on your tone, maybe on your code, maybe on your instruction following, maybe on your structured outputs, whatever it is, right? Having said that, there is actually benchmarks. So let's find out some good uh, leaderboards. Okay. So there will be reasoning. You might already know, I have not covered it so far, but reasoning models are basically trying to mimic the way that we think about solving a particular problem. I have to go from Bangalore to Delhi. Okay. My options are that I can go by road, I can go by flight, I can go by train, bus, whatever it is, right? Now, what is the best way given that I have a time constraint, right? Okay, flight seems to be the best method, right? I may not think about it aloud, and this is a very simple example, but think of a mathematical problem. Think of a theorem that you are trying to introduce and so on, right? Whenever that happens, it generally requires some level of sophisticated step-by-step thinking. And these large language models, they don't think by themselves. It's not as if they're humans. Yes, they have been fed a lot of examples of such types of reasoning. Okay, I'll give one example. There's a company called Invisible Technologies. Okay. Again, you don't need to look this up or something. This is an idea that I'm giving you, that how are these large language models actually um, trained, right? So they actually go to people who are experts, and then they are responsible for collecting specific domains knowledge or maybe reasoning type of data. So you, if you work for this company as a freelancer, you will be responsible for um, thinking or writing down steps that you had when you are actually performing a specific task, right? Then the large language model, let's say OpenAI or Claude or Anthropic or whatever, right? They will be responsible for using that data to train the models, and that is how you get the reasoning. I'll show you an example of how reasoning looks like. Grok, I believe, uh, does a good job. Let's see. Uh, okay. I want to find out the latest about Indian stock markets. Okay. So think of the various steps that it is performing. All right. What it is likely to do. And let's put this same prompt while this is thinking to some of the other ones. Let's go for Claude. So it is searching the information because the large language model itself has not learned a lot of different things, or maybe it has learned things up till until the point it was released, right? So it searched for this information. Where do I find information about Indian stock markets? So it did a web search in the back end. It looked up for some specific information, and then it scraped that data, and then it tried to generate a response for us, right? So this is reasoning, tool calling, web search, all put into one. All right. That's essentially some of the capabilities of large language models. We talked about open source models. Again, any exposure to open source models, anyone? Have you used it in your workflows through either chat or through API? Um, like some of the Chinese models in the last 6 months have been extremely powerful. DeepSeek, Quen, there is GLM models from ZAI. Meta, of course, has released Llama set of models. Any experience or exposure to open source? Okay. Quen. Okay, good. Yeah, Quen models. Firstly, we have a lot of models. There are models specifically for reasoning. There are models specifically for coding. They also have small models, which mean you are able to download it and then use it for your own specific purposes, right? So that's basically some of the aspects. All right, let's do something hands-on now. This is for folks, I believe many of you. I'll put a link in the chat. If you can please open this Google Colab link. This is basically Python. We are not going to do a lot of coding, but we are going to, just like we are able to go to a large language model, go to chat options, and then get that. Here we are trying to bring LLMs to our environment. Okay. My environment is say Python. I want to do some summarization or classification or something on my specific use case and my data. We are able to do that using this specific case. Please try to access this link, everyone. I'll wait 1 minute to see if there are any questions. If not, we'll move on. I will be showing you how to go to Open Router and getting a key next. But just to access this LLM, sorry, this Collab environment itself, if there are any questions, please let me. Accessible. Okay. Okay. Good. If there are questions, feel free to ask. Yeah. Okay. Um, let's start. So the step one would be to go to Open Router. Um, I'll put the URL in the chat also. Um, um, LangChain and LangGraph for LLM is open source? I would put it this way. Um, these are open source frameworks, yes, which means you can freely use them. But the core LLM access that you will do through LangChain or LangGraph, that will of course be paid. Let's say you are using a web scraping tool, something called SERPing, right? If you use that for accessing the internet for your specific application, this is a question from Dr. Sharbani Bhattacharya. I'm answering that. Then yes, you might need to pay for that as well. But this framework of LangChain or Llama Index or LangGraph is free, open source, right? So you are able to see the code and then utilize it for your own use case. Okay, so go to Open Router. Please create an account. So I'll quickly sign out to show how does it look like. If you have not created an account, you can go ahead and quickly use your Google credentials and create an account for yourself. Um, I already have an account, so I'll just click on sign in uh, and go to the right top menu that you have. It should automatically drop down. Click on the second option that's called keys. If you're creating this account for the first time, you will not have an API key, which means you click on this button which says create API key. You can put in any name, let's say test. You don't need to put any credit limit. We are using the free option and you click on create. So it will give you a pop-up with a new key. You can copy this and you can store it somewhere safe. Okay. It says you won't be able to see it again, which is true. But if you don't save it or somehow you misplace it, that's also perfectly okay because you can come here and create another key. So it's as simple as that. Take this key, copy this, go to the Google Colab link that I have shared. I hope accessing it for the others have not been a problem. I got 4 or 5 confirmations that it is accessible. Others, please let me know. Accessible. Okay, thanks for. Um, so once you have the key, I'll repeat once again. You go to openrouter.ai, log in maybe using your GitHub or uh, Google credentials. Once you do that, on the right, you will see the drop down menu, go to keys, create a new key, copy that key, go to the Colab notebook. It's a Python environment. And on the left, you will be able to see this secrets option. See this key option? It is the third option that you see. Find code, and the third option is the key. Okay. So what you will do is you will go to add a new secret. You can write open router API key. You will write exactly this. Okay. Don't write anything else. Open router API key. Aditya, we are trying to access large language models into our own Python environment. Okay. So I'm using a sample code which will connect to a third party open source model developer. Okay. So you can, I'll give you the link to the notebook. Okay. This is the notebook that you can follow. And we will use this to make a call to the large language model. So you write exactly open router underscore API underscore key. and the key that you copied should be put over here. Okay, in the second option. I'll wait 30 seconds. If there are questions, please ask. If not, I'll show how it works. Okay, almost 60% of the folks are done. Thank you so much. Doing it now. Okay. I have faced an issue. Folks who faced an issue, guys, I'm here. Please ask questions. Put it in the chat. I'll be able to help you. But okay, since some of you have faced issues anyway, let me show what to do once again. You go to open router. Okay. Uh, you should log in using some credentials. Google should be fine. Go to keys, create API key, put in some name, say test or personal or whatever you want, and click on create. It will create a key for you. Take that key and go to the Google Colab notebook that I gave. On the left, there is a secrets option. It's a key. You will put the name here. Add a new secret. If you don't have anything, it will be the first one. You will put exactly this OpenAI open route underscore API underscore key. Put your key over here, and that's it. You're sorted. You don't need to do anything else. I'll wait 20 more seconds, and then I'll proceed. Okay, good question. Somebody is asking why open router? No reason. Um, there are many more. Let me quickly open and show you that we are using just one of the options. Yes, open router is kind of special, and I'll talk why. So there is also Grok, GROQ. Okay. Uh, it is slightly different in the sense, firstly, what is open router? Let's understand that. Um, Again, I'll not spend too much time, but very quickly. So we have understood open source models. It can be downloaded, but maybe your system is not too powerful to handle these models and run them. Okay. Now, but they are open source, which means you still need to access it somehow. Either you go to the provider themselves, if at all they give you a UI for that. You can go to Hugging Face, you can go to Open Router, you can go to Grok, you can go to Together AI. You will not believe, like I know 5 or 7 examples, but there are many, many, many more. Okay. So there are a lot of providers. Grok is one of them, but Grok, sorry, Open Router we have considered today because it is one of the options that provides us a lot of free API tokens. All of them do tend to provide some free options. Okay. But Open Router gives, just as an example, go to Open Router once again. There's an option on the right menu, right top menu called models. Just filter for free. Okay. So these are the models that you can access, certain limit, I think 50 calls per day or something. They give you access to these models for free on a daily basis. If you hit a limit tomorrow, again, you can try. These are some of the best models. GLM is a very, very good model for coding and reasoning. DeepSeek, you may have already heard its reasoning capabilities. Quen, again, a Chinese model, does something very well. Microsoft has some free models, right? It gives many best models for free. Of course, there's a limit. They cannot sustain this freely for a very long time, but it is available, right? It keeps some of the best models also, newer models, cheaper models, and all of that. So that is why for now, demonstration purposes, open router, but you should try out few of the models on your own. Okay. So that's basically the context. I hope this is done, everyone. I saw most of you had given confirmation that it is good. Now, this key is not visible to anyone. It is stored here. Okay. And that's the entire point. So it's in a secure place. In this notebook, you can call this. If you are on your local system, let's say a Windows, there is something called environment variables. You can search for that. You can store your key there and work locally on your Python. Okay, that's also available. Depending on the environment, you will have a different way of storing this and calling it, but the principle is the same. Okay, so what are we doing over here? If you are building out, say, financial services, which is an advisory that is powered by AI, okay, by large language models. You want to build your own system. So you have your entire harness. You have your logic that please look at what are the avenues that I can use for my investment purposes. Maybe you can put money in the bank. Maybe you can put money in bonds, or you can put money in mutual funds or hundreds of other options that are out there, right? Now tell me, basis my specific context, what is the best thing that I should go for, right? Earlier, there used to be calculators, home loan calculators, mutual fund calculators, blah, blah, blah. Even today, they exist, of course. But if you were to bring all of that together and you want large language models to contextualize that information in some way and provide tailored responses to every user, you want the large language models capability in your own environment. Okay, so this is a first step towards doing that. Again, I believe some of you folks already have experience doing it, but for the large majority in this group who do not, right, we are in this environment through this key, right? You want to go to a hotel, you open that door using a key. Okay, so we have gone to the hotel. Hotel is called open router. You are going to a room, which is a large language model. I have selected Quen. Okay. I just selected this for the purpose of this call. So search for Quen, right? Or search for Quen free, right? There are so many models available for free. I chose 30 billion parameter model. Okay. So what did I do essentially? I clicked on this. There is a sample API that you have. APIs, that code snippet, it's called a payload in technical terms, which will have what is the access functions that you require and so on to make a specific call. It will have it for all uh, different languages. So you can select Python, or you can use OpenAI, whatever you want. But essentially, this is the URL that you will hit. You have already created the key and specified it in your Python environment. You can keep all of this free for now. And you are telling the model that this is the model that you want to hit. Who are you? You are a user and you are asking what is the meaning of life. This is exactly what I'm doing over here. I've taken exactly that example and I'm going to make a call. Uh, I just responded. There's Grok, Together AI, Hugging Face, and there are many more, very honestly. Um, it's going to be somewhat different in terms of what is the dollar cost, what is the latency, but roughly they all do the same. Akash has a good question. He's asking about something called Olama. So what is Olama? And there is also something that is known as LM Studio, or let's say Llama Factory. Akash, to answer your question, it's not necessarily a cloud interface. Okay. Olama is meant to be a framework where you can download the models. If you have a system powerful enough, you download Olama on your system, you can chat with those models that you've downloaded, or you can fine tune those models. Or if your organization, your enterprise is working about, is trying to fine tune these models, then you can use Olama as a framework again to download it and manage it. Same is the case, as I said, with LM Studio. LM Studio is mostly for chatting with it locally. Llama Factory, you can download it, or you can download C++, right? So all of these options are available. All right. They are more for downloading open source models, working with them locally and fine-tuning them. That's the whole purpose. Okay, so I made a specific call. When you want to run this, you click on this play button over here. Okay. You can change this. Essentially, this is the prompt. When you go to a chatbot, let's say, tell me about LLMs in only 3 lines. Let's see if it follows the instructions. Okay, it is giving us an answer. LLMs are AI models, blah, 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 line 1, line 2, and line 3. So it has followed instructions very well. It has answered the context, right? I'll wait another minute or so, guys. If there are questions or any trouble that you are facing, it is straightforward. Just change this line. That is enough. Try out something different than what I did so that you get a feel for how it works. If there are any questions, please put it on the chat. I'll try and answer those. Okay, Victor has a question. How will you mold this into a rag? I will explain that. Uh, okay. First of all, okay, let me go to. Okay, let's talk about rag. It is possible you have heard of this term, especially if you are a developer of some sort. You could be a data scientist, machine learning scientist, computer scientist, software engineer. It's a common term around. What does RAG really mean? RAG means retrieval augmented generation. I gave an example earlier. Let's say, what is the um, temperature right now? I'm asking this to say Gemini or say, sorry, Quen. Okay. Quen does not know where am I. Quen does not know what is the temperature around where I am. Quen maybe it does not know what is the time. Okay. But if I give it access to information like time, location, and a weather API, right? The model should be intelligent enough that it should know that it has to do that. If it's not intelligent enough, then it will fail. But if I give access to specific information, then it will be able to perform, right? This is technically tool calling. It's not RAG, but the concept is the same. Okay. In your organization, so let me go back to the example to explain how this can become RAG. Okay. There's a lot of pre-work because in RAG, please understand, um, there's a lot of pre-work. LLM are the last stages. So broadly, what happens in RAG is all your relevant docs are ingested. They are embedded, which is, as I told you, any machine or algorithm does not understand words. So it means it has to be converted into embeddings or vectors. We have to put a search into place, let's say lexical or DM25 search, plus ideally a semantic search. Um, Once this happens, whatever the top N, let's say top 10, top 20, will get passed to the LLM, and the LLM will generate a response. So now if you would have observed, the LLM is the last stage. In order to create a RAG, there's a lot of harness we need to build around it. Okay. You need to have all of your docs. Uh, there's a lot of pre-processing you would want to do on that docs. Get it embedded, then put in a search, test it, and then pass the relevant stuff to a LLM. You saw what Grok did in this example. Where did we create that? Sorry, we used it in Claude, right? I asked it about latest information on Indian stock markets. It understands its limitations, that it does not know the right latest information available, which means it did a search. It scraped that information. So this is also RAG, right? Information is out there. You synthesize it, search for it, find the relevant things. And basis that information, you do this. Make sense? Awesome. I'll answer a couple of questions that I see. Just give me a minute. I'll finish this example and then I'll go to those questions. I'm just doing a slightly different or slightly advanced case, nothing too complicated. So when you train, if you have again any background as a developer, data scientist, you would already know this. We looked at that restaurants reviews, right? I love this product. It is amazing. This is a positive review. Worst experience ever, negative, right? And so on and so forth. You have a lot of manually tagged or somehow you have labeled data available for you, right? Now you're asking a large language model to do this. Okay, that look at each of the reviews and tell me if it is positive or not. So you run this function. Again, your key is set. You don't need to make any other change. So it is saying, I love this product. It is amazing. Positive review, and so on and so forth, right? Now, if you are a restaurant owner, if you have apps that have reviews, if you own a product and customers are talking about it, good things, bad things, questions, bugs, feature requests, blah, 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 you are able to pass that on to the LLM and get some specific output for this. Make sense? You can do this at scale. Okay. Now, whether this is the right way to do it or the most efficient way of doing it is a different question. And one final example, go to the function calling example, everyone. Um, so we go to the third function calling option. Here I have created two functions. Okay. One is summarization. So whatever text you have been given, summarize that. Second is to extract capital words that look like names. Okay. This is sample text. Alice and Bob went to the park, blah, 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 blah. Okay. And then, so this is the context that you are passing. This is the instruction that you are giving to the LLM. Given this text, which is this, decide whether to summarize or extract the names and return only JSON and etc. This is basically structuring the outputs. We use the same open router Quen model to do this. And depending on the ask, it first chose what needs to be done. Okay. So what needs to be done, what it has chosen for a particular task is something that needs to be done. Okay. And it has done that in a clear manner. It has been given multiple options that you can do these 500 things. It will need to decide which one or more than one are the relevant to perform a certain task, perform that task, and then be able to give you an answer, right? So again, a slightly more advanced function. Now think of it. It has access to computers, it has access to Python, it has access to some tools that you need for getting some latest information, weather information or stock prices and stuff like that, right? It needs to access it and then be able to create a specific output from that case, right? So all of it is something that is very possible to do. Okay, I'll answer a couple of questions. So what other SDKs do we have? Okay, good question. You can go to any of the other providers. All of them have their own options. So as an example, go to Grok, G-R-O-Q. I'll log in. and you can get the API key just like we got for open router, and you can start creating stuff. Okay, key is possible. You go to docs. Docs gives you how to get started, right? So there is a sample Python code or curl, whatever terminal you want, and then you are able to access it. So many different providers, but a similar construct, nothing too different. Varun. Sorry to take back. I'm trying to run my model. It takes me. Okay. So very quickly, where is the OpenAI Open Router API key to be stored? Take that key and store it here. Come to Collab, please. This notebook that I have shared. On the left, there is a key option. Secrets, it's called. Go to add new secret. Add this word here, variable, and the key that you got, paste it over here in the second column, and then try running it again. You should be good. Uh, Akash, some Akash, sorry, I didn't get your question very clearly. If you can explain that again, please. Okay. Uh, I'll wait a minute, guys, while you are trying this out. If there are any questions in terms of implementation or what more we can do on these examples, please let me know. Uh, we'll try to solve it before I go back to the slides.
If anyone has any questions, they can just raise their hand. We can unmute them.
Done. Okay. Does this give you an idea of what is possible and what did we do? Again, just very quickly. We all know we go to chatbots to help on our daily work or daily personal stuff, right? But think of becoming a developer. Okay. You are doing your thing. Let me go to an example. When I was preparing for this uh, session, I was a bit lazy to create my own PowerPoint. Okay. So yesterday, what I tried out is this option, gamma.app. Maybe some of you already are using it or know about it. I'll put it in the chat, right? Say generate, uh, create slides for explaining how do LLMs work. Okay. So you see, LLMs are within this context. Not everything is done by the large language models. Okay. That there should be 10 slides, or maybe the style should be something different. Let's allow it to generate it now, right? So it will generate a PowerPoint. So the harness, what is in simple terms, what I mean is the framework is belonging to this provider, Gamma. Large language model is connected in this environment so that it generates the content. That's it. But these slides, the formatting, the beautification is not done by the large language model. You can have a large language model that does that as well, but that's not the case in most of the cases. Clear? I'll put this app in the chat again. Likely you guys have. Uh, yeah, name of the API key. Okay. All right. That's basically the point. Done. Done. Yes, you use it for your college work. think of building more than, just prepare it for my assignment, right? Amya Ranjan, this is like just making this up. Let's say you have to finish an assignment tomorrow, right? It's easy these days. You give it some information, you ask it to format in the way that your college wants or your teacher wants, and then you're able to do that. Yes, great. But what if you build a product which is specifically made for that use case, right? You give it to all your friends, your colleagues, maybe create a product out of one or the small startup of your own that does this, right? Because it is a very useful use case, correct? All right. This question. Cool. Now, let's go back. I think we've done some hands-on, so I hope this was helpful. I'm going to explain some more large language model concepts. I will be talking for another few minutes. I don't want it to be a boring session. That is why I took the hands-on session in the middle. So when we talk about large language model, there's a parameter called temperature. Maybe some of you guys know about it. Uh, there are cases where you need an output to be very specific, very accurate. But maybe there are cases where you're writing poetry or writing a storybook and you want ideas that are very different, very creative, for example, right? So temperature as a variable controls for how uh, specific or how creative your answers will be. Okay. Especially when you use this through a API. Okay. You have this option. You should definitely use this option. Higher temperature values, say zero point 0.7 or more, 0.7 to 2 as an example, will give you more creative outputs. Lower temperature will give you clear, focused, specific, accurate outputs. Okay. So that's one of the core uh, parameters that you should be able to use. There is also a concept of top K and top P sampling. I told you already that the large language models have been trained on everything in the world, or whatever is freely available at least, right? So when we talk about these models, when it generates the next token, if it has the options to generate the next word from say 10,000 different words, the output could be not very useful, not very accurate, and so on, right? So what we really want to do is control what seems to be something very specific. So again, just like temperature, in principle, there are a couple of other ways to control um, how broad does it look at. Okay, like I like pizza. Okay, I don't want to look beyond pizza at all. Maybe there are 1,000 different dishes in the world. I am not concerned with that. I like pizza. Okay. Someday I'm feeling adventurous and I want to try out something different, right? It's that. Okay. Tokens and context window. So I'll explain the concept of tokens first. I'll put this link. I encourage all of you to open this link, please. I'll explain the tokens. Brinda, I'll come to your question. Give me a minute. So I've put in some text over here. Okay. You guys should also put in some random text. I have been talking about words or tokens quite a lot. Okay, this is what it really means. I've put in some random text over here. It will break down this using a tokenizer. Okay, when we talked about the transformer as an architecture, it basically parallelizes everything. What do I mean by that? It attends every word to every other word. The way it is able to do that is first it will have to break these words. All right. So this is basically a tokenizer that will break stuff. So whenever you get charged for using LLMs, okay, I'll quickly cover this topic, everyone. LLM's dollar cost is generally per million tokens. What is a token? This is a token. This application is one token, helps is one token, and so on. But the charges are different for input tokens. Input is what we ask, say $1 per million tokens. Output tokens maybe say $5 per million tokens, something like that, right? Different LLMs, different labs, depending on how intelligent they are, they will have a different pricing strategy. Okay. So this is a good thing to remember, especially if you're building with LLMs or you're a product manager or you're a developer, you cannot escape this. It's a very fundamental concept. Let me talk about context window a little. Um, Context window is something like how many tokens can an LLM handle in a single session. Okay. Sorry. This is the simple definition. When you go to ChatGPT or Gemini, right, you cannot go on and on and on for days, right? Or you cannot paste all of Harry Potter's book and say that, hey, tell me about this one specific event. It won't work, right? Because they have a specific limitations. Earlier, it used to be very small, 4,096 tokens. Then it got increased slowly. Now we have Google Gemini, even Claude models that have more than 1 million or even 2 million context window. So in a single session, it can absorb all of that information and give you a specific output. But, and again, this is important. This is what I have faced as a practitioner, but there is enough research around that you don't want to stuff the large language model with as much of information as possible, right? Open a new chat window so that it is fresh. Because if you keep on talking to the same window, right, same session, it gets contaminated. Okay, the performance gets lost. Okay, so it's always a good idea to have short things. Multiple calls is fine, but have shorter things, even if your large language model can theoretically have 1 million or even 2 million tokens as the context window. Clear? Any questions around it? Please let me know. Brinda has a question. Can we call this product? Okay, Gamma app, right? Good question. Can we call this as an agent? Yes, we can definitely call this as an agent. Essentially, think of agents as something that performs a certain action autonomously, right? Given some directions. So that is an example of an AI agent. But I want to call this out, Brinda and everyone. Agents are also a term that is a bit misused, abused. Okay. People call everything as an agent. It's not necessary. Whenever you are doing something deterministic or rule based, logic based, that is a workflow. Okay, you can have LLM in the mix, that's fine. But if you know what you're doing, if there's an if else going on, it's a workflow. If there is some level of autonomous actions that a workflow performs, I would say that is an agent. Right? Uh, all right. That's all clear about tokens and the concept of uh, windows. Sorry, tokens and context windows. If there are any questions, please ask. In what way is the performance deteriorating? Varun, very good question. So, uh, performance can deteriorate in few ways. Um, it may not follow instructions very well. Okay, so it may be a problem in this area. Like you keep on saying that do this, but after a point in time, the same session stops performing very well. Second is adherence to data we have provided. So maybe we have provided it some specific information, say at token 50,000, but now you are at 800,000 as an example, right? It may not be able to look at everything in one go, even though theoretically they will function, but it might miss out on that. It is a known fact. There's a problem, Varun, good for everyone to know. Uh, Lost in the middle. Okay, there's a good paper that I don't want you to go to the paper, of course, but just know this that um, generally, if the answers are in the middle, okay, you give it a million tokens, maybe somewhere at around 500,000 mark, you had the answer. It will not perform as well as opposed to when the answer is at the beginning or at the end. These are known problems. So generally, these are the things. There is also a latency problem. More the data you throw at it, the response will be slower, expected. Dollar cost is more. So as an example, Varun, greater than 200,000 tokens, the pricing tends to be higher. This is true for Claude as well as Gemini models, right? Because I told you at the beginning that every word attends to every other word. So it's a quadratic measure. Now it's a lot of strain on the GPUs and Google's TPUs, so they charge differently. So from all these aspects, the performance is worse or the dollar cost is more and so on. I hope this is clear. Conclusion about tokenizer. Okay, tokenizer is very simple. Ataul, see, when you pass in a sequence, let me try and pass something here, right? I take this random text and I'm passing this over here. Because every word needs to attend to every other word, that is the core of the transformer which powers the large language models. The first step is that it will have to break it down, right? And the dollar cost that you will pay for using a large language model is also based on the tokens that it has processed. So for both of these things, a tokenizer is necessary. A tokenizer is not set in stone. General principle is you have to break it down into manageable pieces of words. But you can see different LLMs might have different um, tokenizers. Okay. So that's possible. Clear, everyone? I think we are at time. I don't have anything else to cover as such. I can take questions either for implementation struggles or any conceptual clarities. Please let me know.
Thank you so much, Ritik, for conducting such a wonderful session and telling us each and everything very step by step and explaining the concepts of LLM in such a clear, practical, and detailed way. Also, we'd like to thank all the participants for joining us today. We have shared a feedback form in the chat. So please take a moment and just fill the form. It will help us to come up with very useful and engaging webinars in the future. Okay, and also if you have any questions, you can raise the hand. We'll unmute you.
Okay, Varun has a question related to context window again. If we were to create an app where context is to be saved with creation of a new session, how should we proceed? It is challenging. Uh, you may have heard of something as LLM memory. Basically, what you are doing is if you hit it, you hit the context window limit, or you want to make sure because of performance issues, you keep the context window small, you will have to pass that context summary somehow to the next chat. Okay, it's doable. It's a known thing. I would say it depends on what is your use case more than anything else, but it's doable. Essentially, the core principle is you try to keep things short. You don't try to overburden it, Varun. That's the core principle. Ways of doing it are really dependent on how you find it um, like what's your use case. But yeah, read up a little bit about the memory of mem0 or lang graph memory. I think that will help a little bit here. Amos, yes, sure, if there are anything, happy to talk. Yeah, these are the prompts that we gave, right? That give me answer about it, or these are the tools that we have access to determine what really needs to be done, or this is a specific review classified as positive or negative. These are all structuring of the prompts in a different manner. um, Banking IT operation. Nizam, I don't think I have like a specific example for banking IT operation. I would say think of the use cases if you are aware of that as a domain, and then think of, are there cases where LLMs can actually provide tailored responses or do some reasoning and stuff like that. Again, very high level I can think of is every time I have to go to my app or my browser to check my bank balance or to make a transaction, right? Maybe the bank now has an interface where I will just give a video audio recording that I need to perform this task. And that after I have given the authentication, it is able to generate that transaction for me, or that getting the balance for me in an automated fashion, right? It knows what I want amongst the things that are available for me, and then we are able to access it. So that's one simple example that I can think of. um, Tokenization, TF-IDF lemmatization. Yeah, so essentially what we are saying is we want to um, break down the words, but we also want to bring it down to its raw form so that um, we are able to associate it to the vocabulary that we have in the model. But also, we are not really concerned with the form or the tense that it really takes. So, yeah, Victor, that's a good comparison. Yes, let's connect on LinkedIn if there's anything specific. Ruhika, I'm a beginner. Think of use cases, Ruhika. You can at least get started with not just the chat, but also getting LLMs into your context. It could be Python, it could be something that you're building. I would say think of a use case more, think of LLMs or AI later. That's usually a good strategy to make it work.